Hello all, good morning. This is Dr. S. Subbalakshmi, an Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now we are on to the topic two-dimensional random variables. In the previous videos, we have seen problems related to two-dimensional random variables, and now we have a problem that the joint probability density function of a two-dimensional random variable x and y is given by f of x comma y is equal to xy squared plus x squared by 8, where 0 is less than or equal to x, less than or equal to 2, and 0 less than or equal to y, less than or equal to 1. And we are going to compute, we are asked to compute probability of x greater than 1 given y less than 1 by 2, and probability of y less than 1 by 2 given x greater than 1. And the third question is probability of x less than y, and the fourth question is probability of x plus y less than or equal to 1. So to start with the problem, we will be writing the given probability density function here. What is the probability density function here? Xy squared plus x squared by 8. So here the x's range is 0 less than x less than or equal to 2, and y's range is 0 to 1. So in the range 0 to 2 only x exists, and in the range 0 to 1 only y exists. So now we will move on to the first problem, which is probability of x greater than 1 given y less than 1 by 2. This is again a conditional probability problem. Probability of x greater than 1 given y less than 1 by 2 is equal to probability of x greater than 1 intersection y less than 1 by 2 divided by probability of y less than 1 by 2. So here we have two separate terms to find, two separate probabilities to find. So now we have taken the numerator alone here. We have taken the numerator alone here. What is our numerator? Probability of x greater than 1 given y less than 1 by 2. We are going to take the intersection of two things here, x greater than 1 and y less than 1 by 2. So what is that? Which is equal to double integral minus infinity to infinity the probability density function f of x comma y dy dx. We have to integrate it with respect to both the variables y and x, since we are dealing with the two-dimensional random variable here. So we have to integrate with respect to both of the variables dy and dx. So here the first range is the first range is for the y variable, and the second range is for the x variable. First range is for the y variable and the second range is for the x variable here. So we already knew that this is the probability density function of the given function, which is xy squared plus x squared by 8, and here the probability of the range of x is from 1 to 2, since we are given in the question as x is greater than 1. And here the range of y is 0 to 1 by 2, since the range given in the question is y less than 1 by 2. And therefore these such range exists. For x we have 1 to 2, and for y we have 0 to 1 by 2. And on integrating with respect to y first, we will be having xy cube by 3 here, as we can see here, xy cube by 3 and x squared y by 8 within the limit 0 to 1 by 2. And after that we are substituting the definite limits for the upper limit and the lower limit, and also we are going to integrate it with respect to the variable x in the next step. So we are going to integrate it with respect to x, so that we will have here x squared by 2, x squared by 2 in the first step, and x cube by 3 in the second step. And applying the definite limits from 1 to 2, we will be having the value as 5 by 24 on simplification. This is what our numerator values have been taken. And for the denominator, so we have got this denominator here. What is our denominator? Probability of y less than 1 by 2. So this denominator is taken here, which means this is probability of y less than 1 by 2, means y's range alone varies, but for x we have the same range as in the given question. So for x it is 0 to 2, and for y it is 0 to 1 by 2. So on substituting and mere simplification, as we have done in the previous numerator step, we will be applying the definite limits also, and on simplifying it we will have 1 by 4 as the value. And now we can just substitute the value of numerator and the denominator in the given question here. We can just substitute the value of 5 by 24 in the numerator here and 1 by 4 in the denominator here. So that what will we have? We will have the answer to be 5 by 6. As we see here, we will have the answer to be 5 by 6. This will be the answer for the first question. Now moving on to the second question. Before that, we will have the same conditional probability here also, and it is given that y less than 1 by 2 given x greater than 1, which means we are going to take the intersection of both the values on the numerator, and the denominator value is probability of x greater than 1. Since the numerator is as similar to the previous problem, subdivision, we will have the same value for the numerator, which is 5 by 24 here, and for the denominator we will just have to integrate it with the x range only varying, which is from 1 to 2, since x is given that x is greater than 1. And on simplifying it, we will be having it as 19 by 24, and on resubstituting it we will have, and on simplifying it we will have the value to be 10 by 38. So this is how we compute a problem on conditional probability for two-dimensional random variables. We will continue this problem in the next video. Thank you.